Alrighty, any members of the media that would like to ask any questions first, please stand up, raise your hand.
Oh, sir.
Yes, I have a question about the eddy current project. With the large amount of ice melt that we have and the fresh water coming over the salt water, how does that affect our current warm water transitions through the oceans, and that in turn affecting our weather?
Or should I shout?
Well, it's a good question. That is a really active area of study, and a lot of people are working on this. The fresh water is, the salt makes the water heavier, and so the fresh water is lighter, and it wants to float. But at the higher latitudes, the water is colder, and so colder water wants to sink, and there's really a sort of dance that goes on between the water being fresh and being cold, and there are a lot of different outcomes that can happen. I don't feel qualified to make a definitive statement about what will happen, but thousands of people are really working on this in different ways, from the glaciologists studying the ice melt to the physical oceanographers studying what happens when this freshwater input at the high latitudes comes in.
All right, next question.
Hi, oh my gosh, sorry about that. I'm curious on the progress on the electric plane and when you expect that actually might be in use, and if you think your data that you'll retrieve once you have an electric plane as far as like CO2, you'll get a more pure and accurate reading on that, or what's your projection for the X-plane, is it called, or anyone?
Hi, so for X-57, the X-57 Maxwell, so for those of you who are familiar with that mission, there are several phases, or what we call modifications, or mods for short. We are currently in Mod 2, which is X-57's first configuration as an all-electric aircraft. The point of X-57, there's more and more electric aircraft in the air, that are going to be flying on a regular basis, and we are trying to excuse me, had to run up here. I didn't expect any for a X-57 question. We're trying to help the FAA set standards, certification standards for electric systems. I didn't hear the rest of the question, I'm sorry.
How do you expect that to affect your data? Do you expect like a pure form of data because you're not producing CO2 from the airplane, so you're going to get more accurate results?
Well, the good thing about X-57 is in Mod 1 we flew a baseline Tecnam P2006T. X-57 is the same exact model, but electric. So we took all the measurements flying that baseline aircraft. We're going to fly the same exact flight profile and get the same, read the same data, compare it directly. So it'll be relative to what we got in Mod 1.
Lawrence, it's for you. I'd like to know how far out this wonderful little vessel goes tracking these waves, and how high are these waves?
So the company who built the wave gliders, when they start this project, they actually launched 3 of them to cross the Pacific. And I think that 2 of them made it over there. So they can stay really long since they just use the energy of the wave for propulsion. They can go for any time. They just need a little bit of sun to charge the battery, so the communication and control unit has enough power. And in terms of wave height they can handle, actually during this cruise through the Pacific, one of them got really close to a hurricane, and he was able to handle sea state with waves, what we call significant wave height, up to 10 meters. And so in real time, we were able to get data like inside the hurricane, and I think they handle waves up to 15, 20 meters, crest to trough.
For a sense of scale, that's like as high as this hangar.
Hi. My question is actually about the Midwest Storm project. So I was born in the Midwest, and I know from personal experience that thunderstorms, particularly more dangerous ones, often result in tornadoes. And I was curious to know what that would mean for your data and what your pilots would do in that situation.
Thanks for the question. So we are actually going to be looking at the most intense storms that happen, because those are the ones that have the strongest updrafts that go all the way up into the stratosphere. And those are also often the ones that are tornado producing. And there is a connection between the two. Storms that are strong enough to overshoot are also much more likely to have tornadoes associated with them, or other kinds of severe weather. But this aircraft over here will not be flying in those storms. It is not designed to handle those kinds of conditions, the turbulence and the hail and that sort of thing. So in fact, we'll be flying downwind, measuring what comes out of them. So we will have to pay close attention, because we need to make sure that the conditions for takeoff and landing are suitable for the plane. But we won't be getting very close to them because of safety considerations.
Here.
Hello. So my question is for Mark with the Delta X team. So I'm actually from Louisiana, the Delta region, and I've grown up around levees. I've run on levees, and there's one right next to my house. And so I just wanted to ask, on one of your graphs, it showed that there was a large deposit of new soil and new land in very isolated, like, single point regions, and then there's a large spread red region where we're actually losing land. And I was wondering, you talked about a few possible solutions. I was wondering if there's a solution that's kind of in the works to help distribute the soil from the Mississippi River and the runoff to kind of spread that sediment deposit.
So I'm not sure exactly the region you're speaking of, but generally, levees are water diversion projects to control the hydrology of the system. They change the transport of water and its sediment into the marshes and may contribute in most cases to degradation of the wetlands. There are I don't know if you could see on the western part of the slides there are two spots where land is actually growing. And that's the Wax Lake outlet and the Atchafalaya River deltas. So those two deltas have been growing significantly in the last few decades. The Wax Lake outlet was constructed to relieve flood in Morgan City. And they just let it go, and the delta at its mouth has been building since then. So the idea is to understand why is it that this particular area is building land and the other ones are losing it. So clearly it's because there's delivery of sediment at the right place. So what is that right place? So there are a few other projects in the work. So we're not in the business of doing these kind of projects. We're just providing the science and understanding and the formulas that can be used to guide those projects, but we'll not be doing that. But there are two projects that are currently handled by the CPRA, Coastal Restoration and Protection Authority in Louisiana, the USGS and the Army Corps of Engineers. And one is in Barataria Bay, so they're thinking of building a channel there, take water from the Mississippi and let that water bring sediment into Barataria Bay, which is more on the eastern side. There's also another project that should bring sediment to the Terrebonne Basin. The Terrebonne Basin is this very large area, this very large bay you could see in the middle of the picture. So there is a project there, a plan to build another channel. So when they build these channels, they make levees, just to deliver those sediments. So they're looking into it.
Hi everybody, my name is Ponley. I'm from New Orleans, and my question, I run a tech company in Miami and Silicon Valley, and my question is about the data. What percentage of it and or how do people access? Is there going to be an open source platform, specifically looking at AI, blockchain, and opportunities to sort of access and connect the data across the different projects? Like, how is that going to look? And then any predictions you all have about what you expect to find in your respective projects, I would love to know.
This is a great question and very good for marketing for the Delta X mission. So the UAV SAR data that will be collected with this aircraft here, this is an operational aircraft. It collects aircraft. The instrument itself, maybe it flies other things, but the UAV SAR radar instrument is operational. So we get the disk, we download it and process it, and within a couple of weeks to a month, it's available for free to everyone in the world. It's kind of hard to, you have to know a little bit of radar to use it, but what Delta X will do is bring the data to a level that's useful to people in general, other types of scientists, ecologists, and managers. And all the data that is produced by actually all of the EVSs will be made available to public freely, open source, everything, even the codes to generate it and the models. So Delta X will deliver, say, science-ready products, which are most likely the ones you're interested in, within about 6 to 9 months after data collection. So because we need some time to come back to the ground with the airplane and process everything. The calibrated models, the numerical models, which include hydrology and the ecological models, will be available within 3 years. So, well, I guess 1 year has already gone by in terms of the project, so I guess a couple of years it will be freely available. So with these models, it's pretty interesting for, I don't know what your tech company does, but if, for example, you plan on building a new levee or doing something around your house, you can actually just carve it and see what happens.
I just want to repeat that all of our data is public, and we all are tasked to get it out 6 to 9 months after we collect it. And it will be in what they call this DAC, D-A-C-C, and NASA DAC. We each have our own place that we're submitting our data. So in our case, it's quite extensive because we collect not only the radar data, which is a lot of information from the aircraft, but we do have ground-based radar. We have satellite information that is from the NOAA satellites that we're going to be collecting, and so it's a lot of data. It's all out there for you to play with if you want. But yes, we are, in order to do this, they require that we make our data public.
Okay, next question on this side. Okay, very exciting. For the snowstorm project, I was curious, you mentioned that it's been 30 years since you last studied snowstorms. Are they getting worse? Why now? And what can we expect for the people on the East Coast? Will they be a little bit better prepared after this study? Or I'm very intrigued, and I know you're about to start next week.
Yeah, I'm about to start. Yeah, interesting you bring out, it's been about 30 years since we studied these storms. 30 years ago, our forecasts of snowstorms were pretty abysmal. We had no idea that there would be an intense storm developing offshore, and our forecast models were completely out to lunch. And that prior study was trying to understand what was wrong with our numerical models. And in the 30-year period of time, the computer power has really expanded and allowed us to make high-resolution model runs. So now we do fairly good with the actual storm system itself, the low-pressure center that's associated with all the clouds. But what we still don't do well is exactly the distribution of snow. Who's going to be the winner? Who gets the foot of snow? Who gets nothing? Where's the rain-snow line? So the data that we are collecting here will help us understand the processes that go into that uneven distribution of snow. So it's we are after the science part, but the science has applications, and the application will be directed towards improving our numerical models. Part of the numerical model is called how does the model create snow in the model, and that is the part that needs a lot of work. So we're doing pretty good about where the track of the low center is, how deep it goes, and especially on a short-term forecast, we do pretty well. As far as how it changes from season to season, that's a bigger question. Our data won't directly address that, but it can potentially be used towards that question. So we're hoping to. But we're mostly trying to understand what are the processes that give you the snow distribution that we are observing and how they vary, and depending on the type of storm and such.
Hi, my name is Larry Stroud, and many of you have projects that directly relate to my life, but my most glaring question is for the Mid-Continent project. Are you guys hoping for any type of implications pertaining to commercial aviation? As a commercial pilot, I spent a lot of time over the Midwest dodging those storms, and I'd kind of like to hope or see if you guys are hoping to find something that may be able to help my career field.
So most of what we're going to be doing, of course, is with this research airplane, and we're going to be flying much higher than most commercial aircraft fly. So I don't really expect any direct products from this research product in that area, or this research project in that area. In fact, we are really, as part of the project, we're really intimately dependent on the aviation system and the way it works now to get the airplane up to where we need to fly it, and to be able to fly it where we want to go with air traffic control and that sort of thing. So we're going to be using a lot of those resources, but I honestly don't expect that we'll be contributing a lot to development in that area.
Question on this side.
Hi, Lynn. My question is about impacts. You mentioned that you'll work with NOAA, but how will you work with the media? Because it's always crazy with snowstorms, where we always freak out on the East Coast. I live in Philly, so we worry a lot, but will you work with the media? Will you calm that down? What's your goal in the future?
Yeah, I wish I could calm it down. Yeah. Well, we will work with NOAA. I have one of my key colleagues is Jeff Wallstreicher and Dave Novak. Dave Novak is the head of the Weather Prediction Center, and Jeff Wallstreicher is part of the Eastern region. And they are extremely cooperative and interested in the data that we're collecting. So we are exchanging information. They're helping us with our forecast because we need to decide when to fly, and we need like a 48-hour forecast to help decide when to fly. And but your question was about how am I going to control the media. I don't know if I have that power. I can tell you that we are posting on social media, and we will describe what we're doing and explain that we're trying to measure and understand these snowstorms better. But it can get out of hand. You're so right about that. Everybody's second guessing the models. The rain snow line is right through Philly. What are we going to do? Is it going to be a foot of snow? Is it all going to be rain? And, we'll do our best. That's all I can tell you.
Hi, Louis Valderas with Lamplighter Media. My question pertains to excess nitrogen in the atmosphere. Some of y'all may know SpaceX had a little mishap down in Texas a few weeks back and dumped a lot of nitrogen with the Starship that exploded. What kind of impact can that cause on the oceans and the environment?
So I'm not familiar with the incident that you're talking about. Maybe it was it liquid nitrogen that was spilled? So actually most of the atmosphere is already nitrogen. So, and that's, the volume is just enormous. So the amount of nitrogen that would be added by something like that would be infinitesimal. It would have an impact locally. If you were too close, it might push all of the oxygen away. But that's really a tiny, tiny thing. So that wouldn't have any longer-term effect on the atmosphere or the oceans.
Hi, this question is more for the ocean expeditions. I was wondering if the concern of large debris, or also known as trash, has this caused any problems with your expeditions, or do you see a future problem? Is this something that's being looked at or evaluated at this time? I'm just curious.
Great question. So when you're out at sea, there is a lot of plastic trash, but you wouldn't really know it when you're out on a boat, because there's just thousands of miles of ocean, and it's relatively infrequent that you come by plastic debris. But one of the instruments that we're using in the S-mode experiment is a Doppler radar that can measure